right, well, at the end of this week, it'll be halfway through the semester. So week 4. Before I get started on the lecture, let's talk about what assignments you have due, just in case anybody's confused. So if you go in Angel, week 4. So this week you have your exam. So obviously the exam's unlocked. You can work on it, then hit save, and then go away from it, come back the next day. You should be fine. And then whenever you're done, you'll hit submit. It auto grades. Then you'll see what your score is. So your exam is worth 75 points, this written part, and then the lab portion is worth the other 25 points. And you'll drop the lab portion here in this drop box. Remember, the lab portion I opened last week. So if you go to week 3, there is the lab portion. So click on that. This comes up. And again, you can do either one of these. So you can either do 1 or 2. You don't have to do both. Just pick one of those. Once you're done, that goes in that Dropbox there. So this week, instead I didn't do a quiz because you already have the exam. So you've got the exam. There's also a 10-point bonus lab you can do and drop it in here if you want to. You do not have to do the bonus. Again, the homeworks are just there for you. It was something the other guy had, but I don't do that. I do the quizzes instead. And then you've got 2 labs, so lab 6 and lab 7 are due. So what's due this week are 4 things. The 2 labs, 6 and 7, the lab portion for the exam, and then the exam. So 4 things are due. And they're due by Sunday, June 28th at 11 p.m. All right, and then this week, the 2 labs, I don't know if I'm going to necessarily do a video on the labs. They're pretty self-explanatory. In this first one, you're a contestant of a game show. There's 3 doors. You pick one, and then he shows you behind the door. So you're making a function to do some random stuff. To generate some random numbers, things like that, and then you're going to run it 10 times, run it 100 times, and so obviously, you know, when you're first testing this program, you don't want to test it 10,000 times, because if there's an error, you don't want it to run the error 10,000 times. You just want it to run 10. If it runs 10, fine, then do it 100. Then you get the idea. So this one's relatively easy, and then the other one this week is you have a time machine. Now this one is a little bit complicated because you have to do it in military time, and you have to be within 24 hours. So as an example, let's say it's 9 o'clock in the morning, and I want to come back to, or I want to move forward in time to 8 o'clock tomorrow morning. Well, that's only 23 hours ahead, but if I subtract 8 from 9, I only get 1. So you need to have something to convert the 24-hour time back to normal time. So when you're doing these 2 labs, don't be afraid to use the discussion forums, ask questions. You other students, more than happy, or you guys should be okay with, you know, hey, here's how I solved it. You don't want to hand somebody the lab and do the work for them, but somebody might be stuck on a piece. How do I convert the 24 hours into 12-hour time? Oh, well, here's how you fix that piece. So I'm okay with that. What I'm not okay with, oh, here's the lab that I did. You know, I don't want you to show them everything that you did. But if they have a problem on one issue, I'm more than happy with you guys discussing that in the discussion forums and helping each other in the labs. That's what it's there for. All right, and don't forget, when you submit your labs, if you have some documentation, that would be great. Hey, this program does this function does this. Here's the function declaration. Here's the function call. Here's the function definition. All that kind of weird stuff. So you get the idea. So there probably will not be a coding video this week. I don't really see the need for it. But if I see a whole bunch of questions in the discussion forums and nobody's answering them, then I might. But other than that, I think you guys are good. So this week's chapter doesn't really give you any new coding examples other than like swapping values. And then the other stuff is more concept. So let's go through this and you'll see what I mean. All right, so the JMX slides, and actually a lot of these I copied over from the other slides. So if you have been following both sets of slides, this week you probably only need to watch my slides because, again, a lot of them are copied from the other one. All right, so we have 2 basic kinds of parameters. We have call by value and call by reference, and you're going to start seeing this in the book an awful lot now. So call by value means a copy of the value is passed, and the value is not changed. Which leads to multiple copies of the value as the program grows. You know, if I call that value 14 times, then I have 14 copies of that value, which obviously each copy takes up space in memory. So remember, every time we create a variable, what we're really creating is we're creating a memory space to hold a value that we're putting in there. And that's why we have to put the type in there, whether it's a character or an integer, because the program needs to know how big of a memory space to allocate to that variable. Also, when we pass values into functions, then they become local variables to that function. And again, they're taking up space inside there. So as programmers, we're trying to create, efficient programs that don't suck up a ton of memory, that kind of stuff. So let me show you an example of a call by value. And really, everything you've been doing up to this point is call by value. So in this program, this is a law office billing program. So we have our IO stream, our namespace standard, and then we create a constant value that's of type double. The identifier is rate, and the value is $150. So we charge $150 per quarter hour. And we have a function. The function is called fee. It is a double. And we have integer hours worked, and then integer minutes worked. And then we start our main. So then we create two variables, hours and minutes, and then we have our another variable that's a double, and it's bill. Now, when we get into here, remember at the top, I created a simple variable named minutes. It's an integer. And then when I went here and I called it in the function call, I'm still using minutes. Later on when I give you the output, I'm using minutes. So the value hasn't changed, and we're passing copies of that value. Now, this value for minutes is copied over to the function fee, and it gets passed here. So what we do is we move the value, we move the 9 or however many minutes you typed in, that value was moved over. So now I have two variables that both have the same value. So I have two variables taking up memory space. So this is exactly what we've been doing up to this point. All we've been doing is copying over values, and we've been creating multiple values, multiple variables that have the same value, which again takes up more memory. So we don't want to work for Microsoft, so we want to fix some of that. So the problem with this, or a common mistake, is trying to declare the variable again. So if in that function, double fee, minutes worked, they tried to declare the value again by minutes worked, you could not do that, because minutes worked has already been passed over the value. We did a call by value. We already passed a value into there, so there's no need to initialize minutes worked because we passed that through the function call. Does that make sense? So if I go back, in the function call for fee, we passed the value of minutes over, and that took the place of minutes worked. So we initialized the variable here at the very beginning of the program when we declared the function. So double fee, and here we declared our integers, or our variable. So there's no need to redeclare that because it was already done. So that's a mistake that they say in the book, but again, I've never seen anybody really do that in class. So moving on. Now, call by reference, this is the new one that we're going to talk about. So remember, call by value is what we've been doing up to this point. We've just been passing values back and forth, creating new copies of the value, which takes up memory space. But call by reference, we do not create a new copy. What we do is we pass the memory location of the value to the next person, and then he actually accesses the value that's in that memory space. So instead of me passing 9, I would pass you the 4-digit hexadecimal number of the memory location, and that way you're using the same value that I'm using, and if the value changes, we're both using the changed value. So basically what we're doing is we're using the original. We're pointing everybody to the location of the original. And we have to indicate call by reference in a special way, so we use the ampersand or the sign right after the type. All right, so let's see an example. So here we go. So here's a program to demonstrate call by reference variables. So void get numbers. Here's a function call, or I'm sorry, a function declaration, and integer type ampersand, and then you can name your variables whatever you want. So the only difference is when we initialize our variables and we put the type in, we put an ampersand after the type. All right, so this is in display 4.2 of the chapter, but again, that's the big piece that you need to get is with the type, whenever we're declaring a variable, when we declare the type, we just put an ampersand behind it, and what that means is when I move that to somewhere else, I will not move the value, I will pass the memory location, so everybody uses the exact same version of it. All right, don't need to go over the rest of that. So again, same thing here. It's a reference, which is why we do call by reference. It's to the actual argument, the location of the argument. Now, call by reference is nice because it saves memory space. You know, instead of having 14 copies of a value, I only have one copy. But on the bad side is other people can change your data. You know, if somebody else calls your data and it's called by reference, they're actually manipulating the actual data, the memory location. So if I change that 9 to a 10, I've changed it throughout the program. So your book suggests that if you have certain locations or certain variables that changing them would cause issues with the program, or have, you know what I mean. Then you make those constant variables. So here I can do, you know, constant space integer, and really, go back to that. So constant integer, ampersand, and then space, whatever you want the variable to be. So again, now normally people do integer and then ampersand. They don't do a space here. And then the space should be here between par1 or variable 1. So I don't know what they were smoking when they made that slide. But you get the idea. So make sure you're aware of that. That's the only dangerous thing about call by reference. All right, and then your book also talks about, your book mentions parameters and arguments, and really, at some places it seems like they're used interchangeably. And they give you the true meanings. You know, a formal parameter is in the function declaration and the function definition. So it's like the stuff in brackets. Those are the parameters. But the parameters can be anything. And then an argument is what's used to fill in the parameter. Now, that's more book talk, and that would probably be a good quiz question if we were actually going to have a quiz this week, but we're not. So, other than that, just forget that stuff. So if you have a question on why does the book sometimes say parameters, sometimes it says arguments, there's your official definition. All right, so choosing names. Same rule as identifiers for when you're doing parameters. You know, you want to do meaningful names. I should be able to just look at the code and figure out what you're trying to do. I shouldn't have to go through the entire code or through an entire equation to figure out what you were trying to do. Between the names and the commenting, I should be able to pick it up, you know, like that. All right, now the book talks about overloading. And I don't understand why they came up with this term, but overloading just means you can have multiple things with the same name. So in this case, functions. I can have 3 functions that have the exact same name, as long as they have different parameter lists. And I'll show you an example of that here in just a minute. But so I can have 2 different functions that do similar things but use different amounts of parameters. And the parameter list is really the signature. You know, if I have one function that rounds things and it takes 2 numbers, then I have another function that rounds things and has 3 numbers, then I've got 2 functions that round, and one takes 2 parameters, one takes, or 2 values, and one takes 3. So let me show an example. So here, I got 2 functions. Both of these functions average numbers. But this function uses a double, and its average is the name of the function. And it has 2 values, you know, the type double n1 and type double n2. And then this one, double average, another function, same name, but it has 3 values. So same name, 2 functions that actually do the same thing, but they both take a different number of variables. So this one has a signature of 3 values. So if you ever call for average in a program, and then you give it, you know, 1, 2, 3, it says, hey, you gave me 3 different values, so I need to use this one because it has 3 different variables to hold those 3 different values. So that's all overloading is. is creating multiple things with the same name. So in this case, we've got two functions, and both functions are named average. They do the exact same thing, they just have a different amount of parameters. And this saves you from doing, double average 1, double average 2, double average 3, that kind of stuff. If you're doing the same thing in a function, it's nice to be able to leave it just the same name. So, like I said, how do you know which function gets called? When I do average equal, or average equal average, and I give you two values, I gave you two parameters. So in that case, it fits this one because this one has two parameters in the function definition. Where if I called it this way, average 1, 2, 3 different values, I'm calling this one. So that's what they're calling the signature. So your function has a signature by the number of values that it needs. And based on what values you pop in there, that's the function that's used. Now, that seems to make sense, and it's very easy. Hey, if I have two values and you give me, or if I have two variables and you give me two values, then I know to use this one. If I have three values and I use this one, it makes sense. But the rule is, the very first thing it looks for is an exact match. If it can't find an exact match, it looks for something compatible. So maybe you gave me an integer value and then a double value. So if I go back here, this one looked for two double values. So it'll change the integer into a double and then use this one. So that's what they're saying. Integers can be tossed into doubles, and doubles might be demoted into integers if that's the only function that I have. So it'll try to make a comparable match based on the number of features or the number of variables. All right, so it looks like this. So if I have three void functions, and they're all called f, this one takes integer n, double n, integer m, and then integer. If I called the function by f9899, this would call number 3 because that one matched the best. It had two values that it needed, and they were both integer, and I gave them both integer. Now, if I called this one, now I got a double and an integer, so this is a double and an integer, so that makes perfect sense, so it calls number 2. But what happens when I call this one? 4.3 and 5.2. Now I'm calling for two doubles. But none of the functions contain two doubles. This is an integer and a double, this is a double and an integer, and this is an integer and an integer. Which function would I call? At that point, really, it's kind of up to the compiler. I would guess it would call function 2 because it would say, hey, the first one matches, and I just got to force the second one. And computers like to do things in order. But we don't want that. We don't ever want uncertainty in our programs. So when you overload, you got to keep these kind of things in mind. How am I going to resolve these things? And when I do my function calls kind of need to line up with the way that I overloaded my functions. So one way that the book talks about solving this is automatic type conversion, where basically they make all the parameters doubles. And that way integers can go into doubles, floats can go into doubles, characters can go into doubles. And they'll talk about more about that in another chapter. But now you don't have to worry as much about types. If I created one of the values and it was all type doubles, that would work easier for everything. So just keep that in mind. And a quick example of that, here I got double mile per gallon, and I got double miles and double gallons. So that's the function, then it just returns miles divided by gallon. So when I call the function, if I do mile per gallon, it would convert 5 and 20 to doubles and then pass them through. If I put these values in, if I do these two double values, there's no conversion that's necessary. And if I sent these values, it would only have to convert the 5 and then pass those into functions. So that's why they suggest, if you're overloading, to create your variables of type double. So that's overloading in a nutshell. We can have multiple functions all named the same thing. They have different amounts of variables, and then when we call them, as long as we put in the number of variables for the function that we want, we're all good. All right. You can also do default arguments, and what that means is we can specify in the declaration a number or a value for the fields or for the variables. So here in the declaration, I'm doing a void function, and the function is called showValue, and I have three variables, length, width, and height. And now in this one, width and height are set to 1. And that way, if for some reason, when I'm actually doing the function, somebody did not pass enough data, maybe they only gave me length and width, height would still be used, and it would be used with a value of 1. So we're putting defaults in there in case something is forgotten. So in this case, if I called it this way, show volume 2, 4, and 6, then I would use 2, 4, and 6, and the 1s would be dropped. So I would change those values, and I would use 2, 4, and 6. But if I did show volume 3 and 5, I would say the length is 3, the width is 5, and I would use 1 for the height because height was defaulted to 1, and I didn't give any change in that. Or if I just get show volume 7, then width and height would be defaulted to 1. So that's a default argument. It's when you set a value during the function declaration, and that way during the function call, if they forget values or values are left out, it will automatically use a certain value. All right, and then in your book, in display 4.8, and I don't remember what page number that is, it kind of walks you through there. So here, I'm doing the void the function declaration. So it's going to be a void function called show value, and I have 3 variables: length, width, and height. And I'm going to set a default value for width and height. And then I'm going to call it 3 different ways. In one way, I'm going to give a value for all 3. In one way, I'm going to give a value for the first 2. And then another way, I'm going to give a value for 1. And then, if we go to the bottom, we see that in the first one, all the new values that they gave us were used. We never used the default values because they were replaced with new values. And then in the second one, the first 2 values were used, but the default had to be used for the third because I only supplied 2 values. And then in the third one, I only supplied 1 value, so the default values had to be used for the second 2. So if you ever have a function that does things, and you don't necessarily need to have all the values in there, you might want to put some default values in there so that if they skip some values or whatever, they still get output based on whatever they need. And for some reason right now, I can't think of a single reason why you would want to do that, but now you know how. All right, swap value. If I want to swap the values between 2 different variables, I can't just do var1 equals 2 and var2 equals var1, because by that point var2 now has the value for 1, and I've lost the value of var1. So what I have to do really is like this, something like this, where I create a function. So this is a void function, and it's going to swap values, and I'm going to take variable 1 and variable 2. So first you create a temp, and you put the value for var1 in there. Then you change var1 to var2, and then you change var2 to the temp. And now 2 has the value for, or 1 has the value for 2, and 2 has the value for 1. Remember, if you skip this, and you did var1 equals var2, you would have, at that point you would lose the value for var1, so it would be gone, because it would be replaced by the value for var2. So you have to have that temp in there. So they mention that in the book. It's a small paragraph, but in case you ever need that, that's really the way it's handled. All right, and then debugging. Woohoo! And this is kind of neat. Lots of different ways to do this. Cout statements. I actually like this. I didn't realize, because I don't think they really talked about it in your book, or I missed that section when I read through the book. And then later on when I had some issues, that really came into handy. And then the compiler, obviously, the compiler shows you at the bottom, hey, you got an error on line 5, you have an error on this line, that kind of stuff. And then we're going to talk about assertion macros, but don't focus on those. We're going to focus more on stubs and drivers in this class. So in your labs this week, you've got a lot of configuring to do. So there might be 14 lines of code, and then your output comes out. But if something's wrong in your line of code, you might not know where it is. Where is the program locking up at? I'm not saying that you have a coding issue. If you have a coding issue, it's going to show up here on the compiler. Hey, you didn't put a semicolon at the end of this. That shows up on the debugger. So we're not going to talk about that because obviously that's pretty easy. But what if your code is all entered correctly, like as far as formatting goes, but your program's not doing what you want it to do? What if it's actually breaking on line 7 and you have no idea? And you're looking at the code and you're like, oh, it all makes sense to me. What you want to do is just pop in some random cout statements. So go to line 3 and put out, hey, cout, this is line 3. And then go to line 8 and then cout, this is line 8. And then go to line 12, cout, this is line 12. And then when you run the program, if the issue is on line 7, you'll see, hey, the C out that says this is line 3, and then you won't see anything else from line 8 or line 12 or whatever else you did. So you know the program broke somewhere between line 3 and line 8. So that was the biggest help to me, especially now that we're going to start moving on in these labs. And there's not going to be a lot of C outs. There's a lot more coding, and then you get something at the end. So when you got 14 or 20 lines of code, it's like, crap, which line of code is breaking? Which piece is not working? So just jam a C out in there every couple lines, and that way when you see the output, hey, line 2, line 4, line 6, line 8, and then nothing, the issue is probably line 9 or line 10. But you get the idea. And then when you're all done and the program works, then you can just go and take those out. And when you turn those in, I'm okay with you just commenting those out. You don't actually have to remove them, as long as you comment them out and they don't show in your output. So as far as I'm concerned, that's good. But if you want to, excuse me, ooh, all right, if you want to wipe those completely out, that's good. All right, and then there's the assertive macro. Let's talk about that. So the assertive macro is just saying, hey, I want to know, is this true or is this false? Or if I'm expecting it to be true, is it true? That kind of thing. And to use these, you have to use this special library, C assert. So again, we don't, when I went through class, they didn't even talk about this. This was kind of skipped. But here's an example. So here, when we give a function, we may create a function to test the precondition and the postcondition. So in this case, if 0 is less than the current coin and current coin is less than a 100 and 0 is less than current amount left and current amount left is less than 100, blah, blah. But that if the precondition is not satisfied, the condition changes to false, and then the program execution terminates. And that way I can just check specific values in there to see if they kick out. Again, don't focus on that too much. I just want to kind of mention it because it was in your book. But stubs and drivers. Stubs and drivers are really what we're going to talk about, and you'll see, you'll get in this class, because our programs are relatively small, you'll get your most bang for your buck out of multiple C-out statements to see where the issue is. But in the bigger or the real world, you'll typically use stubs and drivers. Now, stub is when you compile things separately, like, hey, I need you to make a function that does this. So you'll design, code, and test your function separately, and then you'll bring it in. So we're working on things in stubs and in small portions. And that way we ensure the validity of each unit that's added to the puzzle. So it's kind of a divide and conquer thing. And then to test programs independently, we build driver programs. So a driver is a set of data or something to push the program to see how it works. So in this example here, this is a driver program to test a function, and the function is unit price. So we create a program designed just around testing the stub or the function. So here they create a program that's going to put in data, and then it's going to use the function and put out output. And then they put in different information and they see what comes out of that function. And then if that function works well with the driver program, then that stub can be moved over to the main program for whatever we're using it for. So that's stubs and driver. A stub, take a small piece, hey, you design this, you design this, you design this, test your stuff, and then when you're done, bring it over. And then a driver is the program that we use to test the stubs. So again, in our class, our labs are relatively small, so we don't get a whole lot of use for that. But just make sure that you kind of keep that stuff in mind. All right, moving on, the fundamental testing rule. Obviously we have to test things. And we don't want to test just the proper way things work, but sometimes we want to put in, improper things. Users are freaks. If it asks you for a number between 1 and 10, somebody's going to pop in a 0. Somebody's going to pop in -1 just to see what your program does. So your program has to take that into account. You don't want your program crashing. We want to minimize bugs. We do not want to be Microsoft. All right. So again, in summary, formal parameter is a placeholder. It's filled in with the actual argument in the function call. That's a call by value. So call by values are local copies. and then call by reference passes the memory address, and we're actually using the actual value of the data. So if I've got it used in 3 places, I have 3 places sharing the same value, and if I change that value, it changes in all 3 places. So call by value is what we normally do, and then call by reference saves memory space by pointing everybody at the memory location rather than the value amount. All right, and then overloading is having multiple functions of the same name. Assert Macro, functions, and blah. So functions should be tested independently, and you can create drivers to test your functions. But most of your programs are drivers that test the functions. So however you want to do it. All right, and that's about 30 minutes on the nose. So again, this stuff, again, I don't think I'm going to give you a coding example. I don't think you need it. Because we've already talked about functions, we've talked about swapping values, we've talked about how to do randoms, so we've coded all that stuff before. And at this point, the labs are not requiring you to do call by reference, which again, all you have to do is add the ampersand after the type of a variable, and that calls it by the memory location instead of moving the value over. And I don't think you need to overload any functions in any of the stuff either, which again, we kind of hit that enough. So this week, just keep this stuff in mind for your notes because you may see it come up in the next exam. And don't forget your 4 assignments you have to do, the 2 labs, the exam, and then the exam lab portion. The exam lab portion is 25 points. The exam part itself is 75 points, so that makes the total of 100. There's also a bonus 10 that you can get, but you do not have to do the bonus. And if you're having problems with a part of the lab, don't be afraid to ask in the discussion forums. And also, I recommend you work on your labs early. If you wait till Friday night and you're having a problem with your lab, I don't know how many people are actually staring at the discussion forums on Friday night. I know I'm not. And Saturday morning, the last thing I'm thinking about when I wake up is go look in the discussion forums. I might pop in Saturday night or Sunday morning, and then by that time, you haven't had enough, and I give you an answer, you don't have a lot of time to get that into place. And it might not be the answer you're looking for, so you might have other questions. So you want to ask questions on the discussion forums early. All right, I'll quit whining about stuff. So that's it. Make sure you get your 4 assignments in this week. And if you got questions, email, discussion forums, something. I'm checking that stuff every day. All right, see you guys.